Welcome to Cell Culture Community, where we explore how bioengineering can transform human and planetary health. We're kicking the show off with a mini series on neonatal health technologies designed for use in low resource settings. Over 3 episodes, we learn about design principles, field insights, and commercial strategies for 3 devices. One, a neonatal CPAP, which helps babies breathe. Two, a phototherapy device for jaundice. And three, a continuous temperature monitor to detect fever and hypothermia with ease. There's also fun asides along the way, like a bit with today's guest about how breadboarding is the closest thing to Lego for adults, and a dive 2 episodes from now into Rice 360's innovative way of prototyping their projects in university classrooms, combining invention with education. Before we get into today's conversation, I want to take a moment to set the stage. What is neonatal health? Why does it matter? And how are we doing globally? Neonatal refers to a child's first month of life. It is their most vulnerable period. In 2022, nearly half of all deaths in children below the age of 5 took place in these first 28 days of life. The raw figure is shocking. We saw 2.3 million neonatal deaths in 2022, and the leading cause is complications associated with preterm or early birth. The important and hopeful observation going into this series is that outcomes vary a lot based on the access to care that a child has. For instance, if we consider babies born before or up to the 32-week mark, we see that almost all such neonates in high income countries survive, while half of them in comparable low income settings are lost due to lack of cost effective care for basic issues such as infections, a lack of warmth, and breathing difficulties. Tanner, our guest for today, worked on a low cost breathing assistance device for this purpose. So let's jump to him. I'm here with Tanner. He's currently a mechanical engineer at Koya Medical and previously worked in the same capacity at Equalize Health. For those of you that don't know, Equalize Health was a medical technology nonprofit that used user centric design to deliver high quality medical technologies at affordable prices. They shut down in 2023 due to funding challenges, but over their lifetime, their devices treated 1.6 million patients in over 80 countries. And some of these devices are still on the market. So it's really inspiring work. Tanner, welcome to the show.
Thank you so much for having me.
Tell us a little about the 2 projects you worked on at Equalize Health, just high level.
Sure. Yeah. So the two main projects I worked on, one was kind of our main focal point project was a neonatal CPAP device. So this is a CPAP designed for neonates that had respiratory issues.
CPAP stands for Continuous Positive Airway Pressure. Neonatal CPAPs help babies breathe by providing two things: added oxygen in the air they take in, and external air pressure that supplements the inward pull we naturally create when we inhale.
The device was designed specifically for these target markets that we were working with, mostly in India and sub-Saharan Africa. There are several neonatal CPAP machines on the market already. However, most of them were designed for areas like the US or Europe, where there's plenty of access to, like, abundant access to resources, essentially. And some of these areas, there may be no access to things like oxygen, electricity, compressed air, things like that. So we created this device, and it is still actually in development, though EH shut down in 2020. This project is still ongoing. Thankfully, it got taken up by this organization, another nonprofit called Global Health Labs, and is still in development. And yeah, but so long story short, the overall goal of that device was to create a neonatal CPAP designed specifically for these target markets that had limited access to resources.
Well, I'm glad to hear the project got taken up because it sounds like a lot of work went into it. Let's step back from the requirements for a second and just get to you were talking about the end user, probably a child somewhere in India or sub Saharan Africa, low resource environment. Um, for a typical project at Equalize Health, how do you start the process of understanding what this context is like, what equipment they have, what they don't have? How does that first part of the design process look?
Yeah, that's a great question, and I think that's actually what initially drew me to work with EH in the first place. Was we put a lot of emphasis on the user and understanding the user. So the very first step was assuming we knew, nothing about the target markets, nothing about the end user, and actually going over and speaking with the people that would be using these devices. So we our team did a lot of trips to mostly India, and that was where we had the most connections to in kind of our target market. We did several trips there, and they talked with a ton of nurses. Nurses are kind of the primary target users for this device, because that's kind of who we're designing this. Obviously, we're designing it for the babies, but the people who are going to be using the device are going to be the nurses, and through that, the travel team really uncovered a lot of these specific needs that we realize were not being covered. And often these are overcrowded, overworked individuals, like dealing with a thousand things at once, with alarms blaring all day long, with varying conditions. Just kind of understanding what environment that these devices at the end of the day would be, at the end of the development process, would be working in. That's kind of where we started, was just really trying to understand the user and understand what their needs are.
That sounds like a really exciting and meaningful way of working because, I think we've all heard about the global health technologies that are the classic examples of failure, where you send someone a complicated device and they don't need it, so they just use it for something else, or it lies there and it's never used by them, or it breaks and they're not able to repair it.
Yeah, definitely. I think you just touched on a really big point, was that when a lot of these devices that are designed and that we use, say in the US and some of these more affluent areas with plenty of access to maintenance, especially, when they break, when something goes wrong, we can fix them or we get new devices. However, one of the huge deficits in these areas in our target markets is actually biomedical engineers. So when these devices go down, we can't bring them back up because there's just not the manpower to fix all of these devices. So yeah, you talked about these horror stories of sending all these broken devices. Essentially, we call it the device graveyard. Is there's this kind of this idea of, a lot of the time they'll get these devices, the hospitals pay for them. Sometimes even places like Stanford and Berkeley will get the newest greatest technology, so they'll donate their old devices, which is great in theory, and it works great for a little while until they break and no one can use them, and they just end up in a pile in the back room. So that was kind of one of the core understandings that Equalize found, really, amongst all of their devices and all of their testing and interviews with users, is like, we really want to try and avoid that and make them as fixable as possible, essentially.
It turns out that what Tanner just mentioned around devices being easy to fix and lasting over time influence his team's design choices in important ways.
So, for example, a lot of, actually, I think all CPAPs that are on the market right now use an oxygen sensor, which is it essentially has an expiration date. It uses it. It's a chemical reaction. Eventually, it's used up, and the oxygen sensor doesn't work anymore, and you have to replace it. But planning for a component that needs to be replaced can be difficult, and if you're creating a device that is meant for these areas that may not have access to the people or the parts to replace it, especially in a timely fashion. So the device we were developing had kind of two different ways of detecting oxygen concentration. One was this oxygen sensor, and one was by using flow, by using a couple different pressure sensors, kind of as backups, where you could calculate the oxygen delivered.
Of course, an oxygen sensor is only valuable if there's oxygen available to enrich the delivered air with. The Equalize Health team found oxygen access itself to be a huge issue.
Um, there is a huge deficit of oxygen access in a lot of these communities. You know, in many facilities here, there'll be a central oxygen kind of distribution. The oxygen is provided using oxygen cylinders, so they'll be filled at a facility, driven out, and then refilled. So there, again, often is oxygen access in these facilities, but it may just not be reliable, or it may be gone and hasn't been replaced yet. It may be taken up by other higher need patients. So we wanted to design a device that didn't necessitate the use of oxygen as all other devices did. It would, of course, have the option to, since that's kind of the standard of care. We figured, and talking to some of the nurses and the medical professionals, that it's still valuable to have that positive pressure, even if you can't introduce a higher concentration of oxygen into the system. And we followed studies that have shown that that's clinically true, and talked to our end users who confirmed this from what they'd seen. So we wanted to basically build a device with a bunch of backups.
I learned that building in just a ton of backups is another core design principle that Tanner and his team prioritized.
So I guess the other kind of backup is we have a pretty beefy battery inside there, so it can last for several hours in case the electricity goes out. So it won't last days. Unfortunately, just a battery capacity issue. But if there is some spotty electricity, the babies will still get treatment. So kind of just like the overall philosophy is just like backups upon backups, is you're able to use this device no matter the circumstances you're given, and able to provide treatment up to the highest possible level that the most privileged hospitals are providing right now, and down to kind of using whatever you are given.
I found the design principles Tanner shared really powerful. My three takeaways: 1. Assume nothing about your user. 2. Build things that are hard to break and easy to fix. And 3, in Tanner's own words, have backups upon backups to empower your users to operate well in whatever setting they'll end up in. In the next part of this conversation, I wanted to learn a little about the actual process of building. There were a lot of creative engineering solutions you had to build. You just talked about the alternate method for sensing oxygen. I'm guessing that's not something that the circuitry or hardware was already out there in a bunch of places and you could download it on GitHub. So what was the prototyping process like? What were some of the craziest things you tried?
Yeah, I mean, I think it was just, as any engineering process is, and as a developmental process is, it's a huge iterative process. It was a huge iterative process that we also held a lot of room for feedback outside our engineering team with, because I think one thing is it's really easy to get siloed inside an engineering team and do what you think is most technically feasible and what the best solution is, but there's so many other opinions that you don't necessarily take into account. So we did many rounds of iterating on these prototypes, and then bringing in the clinical team within Equalize Health, as well as going to these doctors and nurses in our target communities, these kind of key stakeholders, key opinion leaders, and getting their feedback. But kind of more on a engineering team level. It was like lots of, we called it breadboarding. We literally, like kind of like circuit board breadboarding. We laid out all our components out on this like perforated board so we could zip tie everything together, kind of just like Lego everything together and try a bunch of different things. So we were able to like rapidly swap out different parts. And it's kind of interesting. I think there's several key components that our system needed, which we didn't have a lot of kind of choice in. There was basically just like one pump that would work for us. And then eventually, kind of similar to like an oxygen sensor, there just weren't that many options. But then it's kind of aligning, how do you build out the internals around these required givens, and there's a lot of flexibility for that, a lot of iteration. There's a heating element that provides humidification.
Our upper airways naturally add moisture to air when we breathe, but the CPAP tubes bypass the upper airways. So air is artificially humidified by heating it in the presence of water.
So we had to make sure we could mechanically make this thing heat up. We had to make sure the software knew it was at the right temperature, to produce this humidification. We had to make sure that the mechanical and electrical side played well together. And so it was just a lot of iteration, a lot of testing to make sure all of these different elements played nicely with each other.
Yeah, that's something that. So I studied bioengineering, but we did some electronics in that. And the first big project I worked on, all of the components worked individually, and we put them together, and nothing worked. So I can relate.
Yeah, for sure. I think it personally provided me a lot of learning, just like on the electrical and software side, like because I feel like a lot of that just seemed from just like a purely mechanical standpoint, it seems like magic. So, but because our team was so small, it was nice because I could get a look under the hood a little bit and understand that side of things more.
Was this the most fun part for you, where you're playing around with breadboards and doing really early stage engineering brainstorming?
I think so. Yeah, I really like the kind of the iterative design process. So I thought it was really fun. Just having everything laid out, having just like requirements for certain areas laid out. We had a ton of 3D printers and a little machine shop that we would use in our office. So we were able to quickly create these ideas and then quickly prototype them and try them out and see if they work and iterate off them really quickly, and able to get better our designs, optimize our designs based off of that. So I had a lot of fun with that. It was just like quickly I think just like making things is the most fun, right? I feel like all engineers go into engineering because they like making things. We're Lego builders at heart,
I was just thinking that it's Lego for adults, the early
Exactly.
prototyping phase. Yeah.
And that's really what the breadboard felt like. We just like snapped everything into place and hooked everything together, and we would swap out some things and we would change some other things.
I will drag us a little bit back into the nitty gritties of engineering. I'm curious about the whole process of engineering for cost, because affordability is a huge, huge thing that separates Equalize Health's products from the rest of the medical market. In my experience, people don't really view engineering for affordability as something groundbreaking or cutting edge or exciting. In fact, most engineers assume the cost of any device will naturally come down over time with small, gradual improvements. I guess, how was your view on this? How difficult was the cost aspect of this whole project?
So I think as maybe in contrast to some design for affordability projects, like that wasn't necessarily the primary focus. Was like, we want to make this thing as cheap as possible. Our primary focus is we want to make this thing you know work as well as possible given the resources that it's being designed for. But obviously, yeah, cost is a huge thing, a huge barrier often. And I think just like there was, that provided a few more restrictions. Like I said, for example, the oxygen sensor, we really didn't have an option, and that was because of cost. Like that was one of the most expensive components in the entire device, was oxygen sensors. And there was like two we were able to try out, and that's because like most of them are extremely expensive. One other way we kept design for affordability in mind was really thinking ahead in terms of our design for every part of the device. So we we designed everything so that it was injection moldable, because that's just in our case would have been the least expensive option for manufacturability at scale. There's lots of different, when you're designing a part, it's like the world's your oyster. You can do whatever you want as long as you throw enough money at it. But we didn't want to throw too much money at it because we don't want the end user to have to, foot that bill. So really every part we made was made as manufacturable as possible. It's always a balance between, function and cost, kind of.
I didn't really know what injection molding was, so I asked Tanner to tell us more.
There's many different ways of manufacturing a part depending on material. And as I was saying, kind of one of the most cost-effective ways of making parts, of making plastic parts in particular, at large volumes, if you're going to make a bunch of these plastic parts, is injection molding. And injection molding is basically, it's like if you have a cast mold that you stick together. It's usually aluminum or steel, depending on how many parts that you're making. And then you have a big plunger and all these little pellets of plastic. And then, so these pellets of plastic are your material, and this big plunger just forces down all of this plastic and heats it up and liquidizes it. So it fills all the gaps of this mold, and then you break it apart, and then you take out your part.
You make it sound so exciting. The breadboarding, the injection molding.
It's pretty fun. Yeah, I was recently uh, prototyping some injection molding using just hot glue, which I'd never thought to do before, but makes a lot of sense, because I guess really that's that at its basic, that's what it is you have a mold and you're just like pushing a bunch of hot glue through it, and then while it's hot, it flows in like a liquid and gets in all the nooks and crannies, and then it cools down and hardens into your part, and then you break apart your mold, and then you have your part. And that's really nice because your mold is made out of a hard metal, and you have this injection molding device that can do this hundreds, thousands of times. So you can just quickly and usually pretty inexpensively manufacture a bunch of these parts.
And are most parts easy to convert into that format?
I think that's with any part, that's kind of one of the hardest stages, is getting it to that place. You kind of, you have, like I said, you kind of get your part to this point where it's functional, but it's not necessarily manufacturable. So you have to maintain that functionality of the part, and then, but change it enough so that it is able to be manufactured using these manufacturing processes. So like, for example, for injection molding, like at its most simple, if you want the part to be as cheap as possible, you just want a 2-part mold. But that means that there's a bunch of different restrictions, because you can only, you can't have any part of any component of your part that isn't able to be pulled apart, or like isn't able to be kind of on this one linear axis. And you can add different slides and different parts that enables you to have different features, but every slide and every different kind of hard tool that you add is more expensive. So you're trying to kind of keep this as simple as possible from just like a casting molding perspective. So there's a lot of, not necessarily redesign, but definitely refinement that goes in. You kind of design them to like 95%, and then that's maybe 50% of your effort. Then the last 5% is getting them ready to be manufactured, and that's your other 50% of the effort.
All of this sounded like really cool and difficult engineering, especially picking and designing parts that balance cost and performance well. Listening back, I found myself really appreciating the rapid prototyping phase Tanner described. In part because it allowed him to adapt so quickly to feedback from the field, but also just because of how much fun he had with it. Day-to-day joy and wonder are so important for sustaining oneself in the long run. In the last part of this conversation, we discuss what made Tanner's work at Equalize Health satisfying and fulfilling. It sounds like there's a lot of creative decisions and little hacks that you came up with throughout this process, and maybe some that are less hacky and just good engineering. All of the backups. We already spoke about the alternate oxygen sensor. What is the one innovation or component or creative hack that you worked on for this device that you're most proud of personally?
I think so. I joined Equalize Health pretty early on in my engineering career, and I think personally what I'm most proud of is it was kind of the first project I was given ownership of by myself, and it was like creating a mounting system for our blower for the pump that blows the air through the system. And honestly, it was a pretty simple design, but it was like my first time going through and creating a part like or creating this assembly by myself, and then also my first time going through and um, redesigning it or refining it for kind of that manufacturability, getting to design transfer side of things. So maybe it wasn't like the most technically complicated or like most technically impressive, but I think just because it was my first time having like ownership over it, I thought that was really fun and definitely provided me a huge learning opportunity. Made a lot of mistakes if mistakes can be made, but made a lot of side steps.
Every lab has its own device graveyard, right? All of the 3D prints that didn't go anywhere.
Absolutely, yeah. We had whole shelves.
I was really surprised by this. It told me something important about the culture at Equalize Health. It was a place where failure was treated as a normal part of the fun and chaotic journey of building. I'm really glad you had this experience, and also early in career, because a lot of people with strong engineering backgrounds get sucked into the traditional kind of big tech pipeline. I suppose for Mackie, that might mean working on uh, the Apple Watch or the Tesla or something like that. What was your thought process choosing Equalize Health early in your career? Many people who graduate want to do something with a bigger uh, brand name or dollar sign attached to it before they get to the social impact stuff.
For sure. Yeah. I think a few things. So when I was in my undergrad, I got kind of more and more interested in like the medical side of things, biomedical. There wasn't a biomedical major. I went to University of Colorado Boulder at the time. I think there is now, or otherwise I probably would have done that. But I was definitely very mechanical side of things, but getting interested in the medical area, and then at the same time got really interested in this concept of human centered design, which is design based on the user essentially. We're not assuming that we know the answer. We're not assuming that we even know the problem until we go and talk to the end user. And I worked with this club for a while called Design for America in undergrad. We'd partner with local organizations, and they would tell us the problem that they need to solve, and we would work with them, not for them, to help create some of these solutions. And I was kind of deciding whether I wanted to do something more design, so like human centered design centric or more like medical centric. And I was really lucky to find Equalize Health, which is kind of the confluence of these two concepts.
He did try working at a big medical device company the summer before Equalize Health.
I did an internship at kind of a bigger medical device company the summer before, and um, I think like a lot of people, it was like that seemed really at the time seemed really like approachable to me. It was a big name company that I knew super well, so it was
Can you name drop for us?
very exciting to go. Oh yeah, I worked for Medtronic. Yeah, which was great. I mean, so Medtronic is like 90,000 employees or something. I think it was a really good experience to intern there. But I think one thing I wasn't a huge fan of is how like siloed and how independent and broken up everything was. Is like obviously I was an intern, but even like my broader team that I worked for that summer was just like this very very small part of this very very huge company, and it was kind of hard for me to really have visibility on kind of what anyone else was doing. So one thing I really appreciated about Equalize Health was that it was a pretty very small team. It was like seven-ish engineers working together to build this device, and even like past that, it was a small enough organization that I knew everyone in the organization. We were doing a lot of educational kind of like some virtual classes for nurses. And even though I wasn't part of that because it wasn't, under the engineering purview, I was able to see that was going on. And, we had these like we had monthly calls or whatever it was, biweekly calls, something where everyone got on and kind of gave everyone a sightline to what the entire organization was doing, which I thought was really like validating. It felt like I was like part of this larger organization working towards this singular goal.
I've reflected several times on how we might engage more and more engineers in this kind of high impact work. This conversation gave direction to that thought. Yeah, personally, also much more of a startup or small lab kind of a person. But I think that's also important to um, hear and note, right? It's not that you chose Equalize Health out of some big sacrifice for society. It was a fun environment for you. You got to work in a way that you enjoyed.
Absolutely. Yeah. Yeah, I think like I was kind of choosing between going back to Medtronic for my first job out of college and then going to Equalize Health, and moving to San Francisco on a nonprofit salary mid pandemic, and was like, let's just do that instead. Let's see how it goes. And I'm very glad that I did that.
I felt like I'd understood what made Equalize Health a good place to work. Its unique design approach, small teams, and communication across silos. But I also wanted to know what made it so effective. Equalize Health did very consistently create devices that did a lot for the patient, and did it in a far more affordable and sensitive way to their context than most people do. If there was one thing you had to say was the secret sauce that allowed Equalize Health to do this, what is that secret sauce to you?
I think the secret sauce is just really the ethos and the passion of everyone in that company. Like, I think everyone who worked at Equalize Health worked there because they really cared and really wanted to create an impact. So I think we were all very driven to create kind of the best devices and the best products, the best services that we could for these users. I think one thing that surprised me when I first started there was our success metric was literally impact. We call it daily effective life years, DALYs, is how we like measured our success as a company rather than like profit, or mainly profit for the private sector.
That's incredible. It sounds like you found work that was personally exciting, meaningful, and of course, for the patients receiving your devices, immensely impactful. We'll talk more about impact measurement with KK, who is in a leadership role at the same nonprofit, next time. For now, we wind up on a more personal note. So you left Equalize Health. What was that process, and where are you now? What are you hoping to do next?
Yeah. So at the end of 2020, unfortunately, the Equalize Health lost funding and had to shut down. I had decided I at least wanted to stay in the medical field. I was basically debating for a while whether I wanted to. I didn't really know what I wanted to do, to be honest. It was a big change, and I think everyone was really sad to see the organization shut down. I stayed in the medical field. I work for a startup in Oakland right now called Koya Medical, and we focus on lymphatic and venous care. So I work on developing these active compression sleeves for lymphedema patients. Some things I really like about it is it's all about patient care and like patient experience. Very few devices on the market right now that treat lymphedema, and they're all very disruptive to the life of the patient. In that usually you're tethered to this large pump box that's plugged into a wall, and the whole philosophy behind Koya was that they wanted to create a device that would make it as minimally disruptive to people's lives as possible. So we make a compression sleeve that instead of is tethered to a wall, has just a handheld controller, so you can walk around and live your life as close as possible to how you live it when you're not using your device. So I really like that. It's kind of like very much impacting quality of life.
There's so much wrapped into that word, right? Quality of life. Like if someone is not plugged up to a machine and they have the compression device on their arm, that might mean they can play with their kids in a way that they couldn't before. I always get emotional about the personal and emotional depth that's behind like everything we have to summarize in quality of life or DALYs, of course, for keeping ourselves accountable with a metric.
Right. Yeah. Quality of life is so interesting because it's so, it's, you can't empirically measure it. It's like very anecdotal by nature. I feel like it doesn't get emphasized enough. I feel like that's like what really matters at the end of the day is just how people feel and how they're living their lives.
That's a beautiful note to start wrapping up on. It's been really exciting talking to you, Tanner. There's a question that I always ask at the end on a lighter and maybe more personal note. What's something simple you do every day for your own health or the health of your neighborhood, family, community?
Yeah, I think recently, personally, for my own health, music is a big part of my life. So I try and do something musical every day, whether it be like practicing or songwriting, even just like intentionally listening to music, something that just keeps me in the moment. And it's even more beneficial if I can do it with other people, like playing in groups, or listening to music with friends.
That's beautiful. Yeah, you already had a mic set up. I think this is the best guest recording quality I'm going to get throughout the whole season. I can see your guitars in the background.
Oh yeah. Yeah, it's been nice. I've been writing songs remotely with one of my friends back in Colorado, so I've been trying to like up my virtual musical setup a little bit to make that as easy as possible. I mean, I think another thing, just like personally, selfishly for myself, is like I think exercise is great. I rock climb, again, preferably with friends, and I feel like it's just like a great way to be in the moment, have some mind body awareness. Yeah, other than that, like talking with friends as much as I possibly can, I think is just like keeping in touch with people drives me.
That's lovely. Yeah, I also got into like gymming basically because of the presence and mindfulness and mental health benefits. I think there's a pipeline of getting into research and then becoming a gym bro.
Yeah, there's definitely, I think for some reason, specifically for maybe mechanical engineers specifically, like there's a lot of mechanical engineers who rock climb. I don't know. I think it's partially like the puzzle solvingness of it is like rock climbing is a little bit like solving a puzzle, kind of like math and science brains like to do. So I feel like I know a lot of engineers who like to rock climb.
I never heard that, but I love that. It is a problem solving. Maybe part of your brain is running what is the quickest way to get up there, kind of
Right,
an algorithm.
optimizations.
Yeah.
Yeah, exactly.
We'll close off there. Thank you all for listening. If you like this episode, leave a rating and review wherever you get your podcasts. This is a part of our launch series. Going forward, we'll bring to you every fortnight a new conversation on how technology can transform human and planetary health. Till then, breathe deep, stretch something that feels stiff, and look around. Notice something curious, delightful, or in need of care. We are gifted with so many chances to love and wonder every day.
Sweet. I love your mindfulness sign off.